This is a continuation of example one, where we are interested in testing the claim that the rate of infection was the same for the two groups. But instead of using a hypothesis test this time, we're going to test the claim by building a confidence interval. So let's just remind ourselves of the problem. We've got two different groups here, the group that's given the Lipitor versus the group that's given a placebo. And we want to know if the rate of infection is the same for the two groups. So the infection rate for group one, we call that P1. And then the infection rate for the people given the placebo, we call that P2. And then the null hypothesis, which contains the original claim, is that the infection rate is the same. Okay, so this is the original claim. And then the alternative hypothesis was that P1 was not equal to P2. And then we told ourselves that that meant that we have a two-tailed test. Okay. All right. So anytime you have a two-tailed test and you're building a confidence interval, and you got to pay attention to your significance level too. Okay. The area in the tail for your confidence interval is going to look exactly like the area of the tail when you do that, the hypothesis test. Again, that's only if you have a two-tailed test. That's not going to be the case when you have a one-tailed test. So here, because this is a two-tailed test, we said that we split alpha in half, and half of the area is on the left tail and half of the area is on the right tail. So I'm going to shade that here and here. Okay. All right. And so if I shade the left tail 0.025, the right tail 0.025, together these two areas represent alpha, which is 0.05. And now we need to talk about what is an appropriate confidence interval. So in other words, we need to figure out what our confidence level is. So the confidence level for a two-tailed test is going to be 1 minus alpha. So if the two red shaded regions add up to 0.05, then the area that's in between, so I'll use my blue highlighter here, this whole area here, this represents 1 minus alpha. So 1, oops, let me use my pen, 1 minus 0.05, which gives me a confidence level of 0.95. So this means that I'm going to use a 95% confidence interval. Okay, so the first thing that we needed to do was figure out what our confidence level is going to be. And our confidence level is 0.95. Once you determine that, then you can go straight to your calculator. So again, there are formulas for calculating this confidence interval, but I'm going to use the calculator function. So on your calculator, use the 2 proportion Z interval. Okay, so again, 2 because we have 2 independent samples. We're dealing with 2 proportions, and then we always estimate that with a Z distribution, and then interval because we're trying to build a confidence interval. So when you put that into your calculator is going to give you a confidence interval of negative 0.0895 up to 0.038. So now let's talk about what this tells us. So if we take a look at this confidence interval, and I'm going to put it on a number line. My number line is not drawn to scale, but I just need to mark 0, and then the lower confidence limit, which is a negative number, and the upper confidence limit, which is a positive number. And so what this confidence interval says is, it says that we are 95% confident that the difference, so the difference between the infection rate of the two groups, right, is somewhere between negative 0.0895 and 0.038. And because the difference could be anywhere in this interval, right, that means that it could also potentially be 0. So if the difference between P1 and P2 is 0, this implies that P1 is equal to P2, because that's the only way that its difference can equal 0. So the fact that it could possibly equal 0 means that it is also possible that the infection rates for the two groups are the same. So because of that, we cannot reject this null hypothesis. So that's why we're going to also fail to reject the null hypothesis. So notice that you come to the same conclusion as when you did the hypothesis test. Okay, so now let's just write out the final conclusion. So based on this confidence interval, we would come to the same conclusion. We would, since the confidence interval contains the value 0, okay, we would fail to reject the null hypothesis and conclude that there is not sufficient evidence to warrant rejection of the claim that, and I'm going to put dot, dot, dot here because it's going to be the same as what we did in part A, and you would just rewrite the claim that the rate of infection was the same for the two groups. Real quickly here, I'll show you where you'll find this function on your calculator. So start by clicking on the Stat button, tab over to the tests, and then scroll all the way down to option B. Here you'll see 2 proportion Z interval. The calculator is going to ask you to put in all the relevant sample data information, and then again, you have to make sure that you put in the correct confidence level. And then once you do that, the calculator will give you your confidence interval, and then it will also remind you of what your p-hat1 and p-hat2 values are. And then again, I always tell my students, double check to make sure that you typed everything in correctly. So double check that your sample proportions match up, your sample size matches up, etc.